Hi there, students. Today I'm going to review with you the test that you took about a week and a half ago. Because we're not in class right now, we are doing this in a different way. Please take this opportunity to learn from your mistakes and improve your test taking skills as we review this. What I'm asking you to do right now is pause this video and take a moment to open your Edulastic. So go back into Edulastic and take a look at what your score is and your answers. Okay, once you've done that, let's resume. So here we are back. So now that you have taken a look at your test, let's take a look at these questions that we have here. So the first question is, which of the following celestial bodies has the most built-in gravity? Well, we're looking for the object, the celestial body, anything that floats in space that has the most mass. And that would be out of this series, the sun, because the sun is massive. As you know, more than 99% of all the mass is in the sun, so that has all the gravity. It determines everything that's going on into our solar system. So the sun, D, would be the right answer. The next question is asking you the following: which of the following best describes why Jupiter, Saturn, and Uranus have the most moons on the chart? And if you look at this, Mars has two, well, you know, Earth has only one. And we're looking at the answers. They are the planets with the most mass. Okay, that seems reasonable. They are the planets farthest from the sun. Well, that is partially true, but Neptune is the furthest away, and that one has only 13, so that doesn't work. They are the oldest planets in the solar system. Uh, no, that I don't know what that would have to do with it. And then they are the planets with the densest atmospheres. Um, well, that could be true, but that doesn't really have anything to do with the moon. So you really need to think about gravity here. They are the planets with the most mass. So A would be the correct answer because they have more mass, they are able to attract more objects that were circling around in the beginning of the formation of the solar system, and therefore they ended up with many moons. Question 3. The law of universal gravitation states that. Now, this question is relatively straightforward, and you guys, you did very well on this, but it's the force between the two objects increases as their masses increase, because we know more mass means greater force. This question was well made. The next question always seems to be a little bit difficult, and this is the one where you have to read it really carefully. The force between the two objects decreases as the distance between them decrease. Well, as the distance decreases, objects are coming closer. So we know actually that as objects come closer, the force will become stronger. So the right answer would be the force between the two objects increase as the distance between them decrease. Okay, I'm almost doing it wrong here. So the force between the two objects increases as the distance between the two objects decreases. So that would be the right answer would be C. Next, we have the question where we have these 4 planet sets, and we need to determine which set of planets has the strongest gravitational force between them. All right, so we're being given the mass here. So A has 2m, 2m. So 2m plus 2m is 4m. So the total mass is 4m. This one is 4m plus 2m. So that's 6m. C is 4m plus 2m. It's 6m. So the same as B. And then D has mm. So this has 2m. So then we're the two that have the greatest overall mass are B and C. But if we look at B, the distance is twice as big, so B would have a weaker gravitational force. Remember, it goes by the distance squared, actually, so you would have to divide by 4 in this case. So this, because of it has twice the distance, the strength would be 4 times as weak, so the winner would be C. So your right answer is C. Now, question 6 and 7 build on question 5. All right, so hopefully you've seen this rubric here too. We also gave you a little piece of paper about that, but here's the rubric. And it says, I used the sentence starter provided. I chose sets that are deselected. I chose 2 sets that are deselected. I describe what the pairs have in common with my selection from question 5. I explain why the 2 deselected sets planets have a weaker gravitational force, and my answer is written in complete answers. The word deselect means unselect. You did not select them. Okay. So an example answer could be as follows. It says, I deselected planet sets A and D because even though the distance between the planets is the same as for set C, the total combined mass in sets A and D is smaller than for C, making the gravitational force weaker for sets A and D. So have I all done this? Have I used the sentence starter? Yes, I did. Did I choose two sets that are deselected? Yes, A and D. Did I describe what the pairs have in common with my selection from? Yes, I see from the question 5, yes, because even though the distance between the planets is the same for set C, right? So that's what I described what they have in common. I explain why the two deselected sets of the planets have a weaker gravitational force. Well, yes, I say that their total combined mass in A and D is smaller than for C, and then I'm explaining that that makes the gravitational force weaker. So I've done all of these things. The next question will give us a opportunity to also explain why we've deselected B, right? Because we chose C. So that could look as follows. So again, here we have the rubric for question 7. I use sentence starters, etc. Why did I deselect that third one? And so on. If you forgot to look at these rubrics, make a mental note of that, that when you get questions like this, that you're really vigilant about looking at all the information that you have available to you for these questions, because that will help you do better on these type of questions. Example answer could look as follows. I deselected planet set B because even though the total combined mass between the planets is the same as for set C, the distance between the planets, correcting, in set B is greater than for C, making the gravitational force weaker for set B. So again, I have done all of these things. Some of you did really, really well on question 6 and 7. Some of you just hit it half-heartedly. I mean, you have to really look at the rubric and be very complete in your explanation when you answer a question like this, just like we practice the days before the test as well. Moving on to question 8. So this gives a little intro. In the year 2356, after colonizing Mars, mankind has learned how to travel at speeds very close to the speed of light. This capability allows people to explore exoplanets. The first team of astronauts to visit exoplanet includes 2 people and 2 monkeys. Some data for these beings are summarized in table 1. All right, so here we have table 1, we have person 1 and 2, monkey 1 and 2. I also see there's another tab here with the equations. So I guess it gives me 3 equations, so I probably have to use some of these equations in the next couple of questions. So back to the table. It says then the above team arrives at a new exoplanet J. The exoplanet J has 0.2 times the mass of Earth and a radius of half that of Earth. Calculate the relative gravity on exoplanet J. Show your work. And it gives us the equation here. It says the relative gravity exoplanet is the exoplanet mass relative to Earth divided by the exoplanet radius squared relative to Earth. So what could that look like? It's you have to show your work, right? Show your work. So that could look something like this. Relative gravity is a half divided by 0.5 squared. I'm sure there's other ways you can do all of this also with superscript and subscript. You have that into your arsenal, but just keeping it simple here. A half squared is 0.25, so 0.2 divided by 0.25, that gives us a relative gravity of 0.8. So that is your answer and the work. If you were confused about this, in the end, there's only 2 numbers here, and it says times the mass, so that was the relative mass divided by 0.5 squared. But moving on to question 9. So now this has the same intro here. It also says the above team has traveled from exoplanet J to exoplanet K. Exoplanet K is different from exoplanet J and has a relative gravity of 0.5. That was relative to Earth. For some of you who were wondering about it, you asked that, so that was good. So what would be the weight of person 2 on exoplanet K? Show your work and explain. Okay, so what would be my relative gravity? I'm sorry, what would be the weight of person 2 on exoplanet K? So before we're looking at the equations, the weight of person 2 is 800 here. And here it gives me the equation. It says weight exoplanet equals weight on Earth times the relative gravity on that exoplanet. All right, so weight exoplanet is the weight on Earth times the relative gravity on the exoplanet. So back to the table. So that could look something like this. Weight on the exoplanet is 800 newtons times 1.5, and that brings us to 1200 newtons. Some of you did not read this well and still used the 0.8. You probably got a little bit, maybe half a point taken off, but if you still showed your work and had the calculation correct, then that would be still partial credit. All right, so next question. We're on question 10. The above team has traveled from exoplanet J to exoplanet K. Exoplanet K is different from exoplanet J and has a relative gravity of 1.5. Okay, what would be the mass of monkey 2 on exoplanet K? The mass. Well, let's see what we have for equations. Oh, there is no equation here about the mass. Ah, I remember now. Right. The mass never changes. The mass is simply the total amount of matter that's in an object, or a monkey in this case, and that will stay the same. It will be 255 kilograms. So, because that's what it's stated in the table. Now, some of you noted that this was a typo. It should have been 25.5. So if you were that clever and observant, if you wrote 25.5, credit to you. But if you just wrote this number here, because literally that's what it says in this data table, that will be the correct answer. Remember, mass does not change, only the weight, because the weight is a measure of the amount of gravity acting on an object. The mass is simply the amount of matter in an object, and that doesn't change when you go from one planet to another. We're arriving at the final question here, question 11. So again, same intro. So now it's asking us what would be the jump height of monkey 1 on exoplanet K? Show your work, explain. Monkey 1, jump height on Earth is 2 meters. All right, so let's take a look at the equation. The equation says jump height on exoplanet is jump height on Earth divided by the relative gravity on the exoplanet. So that's the equation that we need to apply. And that could look as follows. So the jump height on exoplanet is 2 meters divided by 1.5, and that is 1.3 meters. It's 1.333. Some of you try to make that repetent 3. It does not round up to 1.4. I saw that data too. Actually, I thought that was not correct. I mean, you can't round 1.333 to 1.4. If you round it, 1.3 is just fine. So that was the last question. So please take a moment to again review what you got on the test. If you do not understand why you got partial credits in certain questions, feel free to contact your teacher. Thank you for watching. Have a growth mindset. I miss you guys, and I hope everybody's doing well. Have a great day.